All right, projectile motion, page 19. Be sure you cut those all out. Start off with this. Glue it in. Glue it in the middle. Give yourself just one line of space above it, no more. Okay. With projectile motion, the first thing you need to learn is the vocabulary, the terminology used to describe projectiles. Okay? So the first thing to start off with is just that, the word projectile. Okay? So I'm going to use 5 different colors to do this. Okay? So my blue I'm going to use first. Okay? Projectile. I highlighted the ball. Okay? Projectile, that is the actual object being thrown. Any object that's being thrown is a projectile. So in parentheses you can write the object. In this case, it's a baseball. Okay? The projectile is the object, whatever that object may be. Okay? Now, the dotted line traces the path it travels through the air. Okay? Highlight the dotted line. That path it's traveling through the air, does anybody know what that's called? It's called the trajectory. 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 The very top tip point, highest point the ball gets to. Okay? Oh, actually, sorry. Detail about the trajectory. Haha. Think about your algebra class. What's that shape called in your algebra class? Parabola. So under trajectory, write in parentheses, parabolic shape. It is shaped like a parabola. The trajectory has the shape of a parabola. Okay? Now, sorry, back to the very tip-top point. It's called the apex. Okay? That very tip-top point is called the apex. Now, from the ground up to where the ball is, traditionally we call this height. Okay? That's what a normal person would call it, or that's what maybe the person throwing the ball would call it, or if it's an archer, they would say how high their arrow went. But in physics, as physicists, we don't call it height. We give it more of a mathematical name. We call it vertical displacement. And we call it that because displacement is the variable in the formulas we use when we want to calculate the vertical displacement. Okay? So, height is vertical displacement. It's the same thing. Yes. Okay? And last, how far the ball goes horizontally. Normal terminology, that's called the range. All right? Ever heard of people going to a shooting range? Okay, that's where the word comes from. The range, how far it goes forward. Well, physicists, mathematicians, we don't call it range. Anybody want to guess what we call it?
Distance.
No. Horizontal displacement. So we have vertical displacement and we have horizontal displacement. Okay, so we throw the ball up into the air, it goes up, it comes back down. What is it that makes it come back down? All right. So, gravity causes the projectile, using the words there, to accelerate. Okay? Gravity. Gravity causes this motion to be what it is. Okay? Gravity is the cause. All right, now glue that piece of paper in. Okay? Try not to leave too much space because we have to still fit another paper below it. So, when we talk about a projectile and we talk about its motion, we actually separate the vertical motion from the horizontal motion because they don't affect each other. That was kind of the purpose of the lab, okay? How fast it's going horizontally does not affect how fast it falls. We all agree? Okay? So, when we're talking about projectile motion, we actually separate the vertical from the horizontal motion. Okay? So, vertical means up and down, horizontal means side to side. Now, the way I remembered it growing up was that the horizon is horizontal. That's where the word comes from. But you have to know what the horizon is. When you're standing outside, the horizon is where visually the sky meets Earth. That's the horizon. Where the sun comes up, where the sun goes down, that's the horizon. It's horizontal. Okay? Now, when we're talking about that vertical motion, if you throw something up into the air, as it's going upward, it decelerates. It goes slower and slower and slower and slower and slower and slower. For a brief moment at the very, very, very top, at the apex, it stops. And then it comes back down, and as it comes back down, that's that free fall motion we discussed before. It goes faster and faster and faster and faster and faster. Okay? Do you all believe me? Do you understand that? Watch. As the ball goes up, it decelerates. As it comes down, it accelerates. So up, it's going slower and slower and slower. It stops for a brief second, and as it comes down, it goes faster and faster and faster and faster. So when it leaves my hand, it has a fast velocity, and that decreases, gets to zero, changes direction, comes back down, and goes faster and faster. So it is, as it goes up, it decelerates to a stop, changes direction, accelerates as it comes back down. And that is projectile motion, the vertical aspect of projectile motion. Deceleration up, acceleration down of a negative 9.8. The upward motion, it decelerates at a negative 9.8 meters per second squared. The downward motion is an acceleration of negative 9.8 meters per second squared. But you're like, wait a second, accelerate, decelerate, what's going on? Notice it's going downward. That's why it's negative. Okay? Deceleration is always negative. Acceleration is positive unless it's going downward. Then it's negative. Okay? Now, the horizontal motion, the side-to-side motion of the object, of the projectile, okay? Its horizontal motion is actually a constant velocity. And how fast that velocity is depends on how hard you threw it. Visual to help explain, the picture of the cannonball. Go ahead and glue that in below. Hopefully it fits. You see here in the diagram with the cannonball, it's showing the cannonball, and these are at every second intervals. Okay? Now, look, they'll say Vx and Vy. Vx and Vy. X is horizontal, Y is vertical. Okay? Look at the Vy velocities. Negative 9.8, negative 19.6, negative 29.4, negative 39.2. Do those numbers look familiar? They should. Negative 9.8, negative 19.6, negative 29.4, negative 39.2.
These are the numbers of free fall acceleration increasing at a rate of 9.8 meters per second squared going in the negative direction.
There, free fall acceleration. It's falling at the same rate as any free fall object. That's the vertical velocity. Okay? So, with whatever color you want, okay? I'm going to use orange. I want you to highlight that down pointing arrow and highlight those velocities. Okay? That movement, that vertical movement, we have a vertical constant acceleration. Okay? Vertical constant acceleration. Now my question is, how fast is that vertical acceleration? All right. Negative 9.8. That's how fast it's vertically accelerating. Negative 9.8. Gravity. Now look at the horizontal motion, the horizontal velocity at each second. Okay? We have a 20 meters per second, and then 20 meters per second, and then 20 meters per second, followed by another 20 meters per second, and it continues on always being 20 meters per second. If it's always 20 meters per second, how do we describe that motion? Constant what? All right. Constant velocity, horizontal. Now, is it always going to be 20 meters per second for every single projectile? No. How big that number is depends on how strong that throw was, or in this case, how much gunpowder they put in the cannon. All right. So, are we understanding? Yes? Hopefully? Okay. All right. Next. My oops page. Take this picture that looks identical to the one on the other page. Okay? This one. Go ahead and glue it in the middle. Sorry, top middle. All right. Now, here's this really interesting little thing about projectiles. Okay? In this diagram, can you see this is the ball, and then like a few seconds later, and then here's the ball again? Okay? The ball right here and the ball right there at the same height. Do you see that? Except right here it's going up and right here it's going down. Yes? Right here they're at the same height. This right here it's going up, right there it's going down? Yes? Interesting little fact. Its velocity. Let's say it's 22 meters per second. Okay? Just giving it a number. Okay? It's going upwards. When it comes back down and it's right there, guess what the velocity is going to be? Negative 22 meters per second. The only difference is it's going up or it's going down, but it's got the same speed, just the direction is different, so we say they're opposite velocities. Okay? So one's going up, the other's going down, but it has the same magnitude, the same speed. Okay? That applies to these two right here. What happens at the apex? Okay? The vertical velocity is 0. Okay? It's moving horizontally. It will have a horizontal velocity. All right? It will have a horizontal velocity, but the vertical velocity, the velocity in the y, the vertical velocity, the velocity in the y direction is equal to 0. Okay? Make sense? All right. Next, now, besides how hard the person throws that ball, how much strength, they put into the throw, what else will determine the shape of the trajectory? So, the trajectory. If I want to change that shape a little bit, if I want to make it a wider one, or I want to make it shorter, or I want to make it taller, I can adjust how hard I throw it, but what else can I adjust? What else can I change? Not exactly the direction, more the angle. The little circles there, angle. Okay? So let's glue this in. The angle the projectile's launch affects the trajectory shape. Okay, so how does it affect it? So there with your colors. Using your colors again. Okay? Circle or highlight the number 75. 75-degree angle. Really steep angle. Okay, get this other piece of paper. Let's go ahead. I'm not going to glue it yet. We'll glue it in a minute, just because I want to be able to write on it. Okay, so 75-degree angle with whatever color you highlighted that. Highlight it here. 75-degree angle. When I have a 75-degree angle, how would you describe the height compared to the others? Okay. So vertically, the height, should we say large? Or do you want to write tall? Does tall make more sense? All right. Put very tall. Haha. Very tall.
Oh, we're gonna paste that too?
Hmm?
Paste that?
We will, but we're going to write on it first. It's easier to write on it before you paste it. Okay? Now, describe the range compared to the others. What's the range?
Short.
The horizontal. It's pretty darn short, isn't it? So you get a tall height, but you get a short range. If you have a 75-degree angle. Okay? Make sense?
Yep.
All right, let's get a different color. I'm going to use green. Highlight the number 45. Highlight its trajectory. Okay, let's describe its trajectory. Let's describe the dimensions of its trajectory. Okay, so describe the height of the 45-degree angle compared to all the others. I like that word, average height. Do you want to say average height or medium height? Which makes more sense?
Medium is like 60 degrees.
Okay, so if whatever makes more sense, average or medium, write in here. I like the word average, it sounds more scientific, so I'm going to write average. But you can write medium. Okay, so average height. Okay, it's not the tallest, it's not the shortest, it's in the middle. Okay, how about the range? How about we say the longest? Right? Is anything as long as that one is? Nope. So I'm going to say the longest. All right. Pick another color. I don't care which. I'm going to use orange. It's a good highlighting color. Okay. Highlight the 15 degrees. Now let's describe it vertically. What can you tell about 15 degrees vertically? It's the shortest. Now it's the shortest amongst here. What do you think if we did a 10-degree angle? Would it be shorter? Yeah. Okay? But of the ones that are shown here, it's the shortest. Okay? What about the range on the 15-degree? That's a short range. It's the same short as the 75-degree. Ooh. Okay? Now, obviously, I've given for you in here 30-degree and 60-degree. If you want to come up with words to put in there and describe them, that would be great. Okay? But most importantly, I need you to see that difference. Okay? Now, 75-degree is very tall, but it's not the tallest. We could get even taller if you wanted to. Okay? Let's take this paper. Go ahead and glue it in below it. Now, one that's not in the picture, but I want you guys to think about it, is a 90-degree angle. What does a 90-degree angle look like? It's a square root. It's a square. It's a right angle. That right there, where the Y is right there, that is essentially the 90-degree angle. If you throw something straight up into the air, the height is the tallest. That's the highest you can get it. But what about the range? What is the range if you throw it straight up in the air? It's 0. It doesn't have a range. Okay? It doesn't have a range. It's 0. I know. All right? So that is the journal entry. This piece of paper we will deal with next week. Tuck it in.